Sometimes we look up at the night sky and feel a profound sense of connection, a connection to something vast, ancient, and utterly magnificent. The stars we see are not just points of light, they are time machines. They offer us a window into the past, into the very origins of everything we know. Recently, humanity's most powerful time machine, the James Webb Space Telescope, peered deeper into this cosmic history than ever before. It has given us something truly extraordinary. It has found a monster lurking in the dawn of time, a discovery that stretches our understanding of the universe to its very limits. We are looking at the echoes of creation itself, a period shrouded in mystery until now. Imagine pointing a telescope so powerful that it can see light that has been traveling for over 13 billion years. That is precisely what Webb has done. The light from this distant object began its journey when the universe was just a baby, only about 500 million years old. This is an era we call the Cosmic Dawn, a time when the very first stars and galaxies were beginning to ignite, piercing the darkness that followed the Big Bang. Finding anything from this period is a monumental achievement. But what Webb found was not just a star or a fledgling galaxy. It was something far more enigmatic and far more powerful, a true titan of this primordial age. This incredible discovery is the oldest black hole we have ever confirmed. It existed an astonishing 13.3 billion years ago. Think about that for a moment. The universe itself is about 13.8 billion years old. This means we are witnessing an object that formed when the cosmos was in its absolute infancy. It is like finding a fossil from the first moments of life on Earth, but on a scale that is almost impossible to comprehend. This isn't just another dot of light in an image, it is a direct link to a time we previously could only theorize about. It is a piece of the universe's origin story, delivered to us across an immense ocean of space and time. The sheer existence of such an object so early in the universe's history fills us with a deep sense of wonder. How did it get there? How could something so massive form so quickly after the Big Bang? These are the questions that drive science forward. They push us to build incredible machines like the James Webb Space Telescope. They inspire us to look deeper, to question our assumptions, and to embrace the profound mysteries that the universe presents. This discovery is not just a scientific data point, it is a reminder of the endless beauty and complexity of the cosmos, a cosmos that we are only just beginning to understand. Now, let's talk about the nature of this cosmic beast. It resides at the heart of a young galaxy, which astronomers have named Capers LRDZ 9. This galaxy is small and distant, a faint smudge of light from our perspective here on Earth. Yet, within this fledgling island of stars lies a gravitational monster of epic proportions. The black hole at its center is not just old, it is unbelievably massive. It weighs in at an estimated 300 million times the mass of our own sun. To put that into perspective, the supermassive black hole at the center of our Milky Way galaxy, Sagittarius A*, is only about 4 million solar masses. This ancient black hole is nearly 100 times bigger. The size of this object is what makes it so truly mind-boggling. According to our long-held theories, black holes are supposed to grow over time. They start small, perhaps from the collapse of a single massive star, and then they gradually feed on surrounding gas, dust, and other stars. This process of accumulation takes billions of years. Sagittarius A*, our local supermassive black hole, has had the entire history of the Milky Way to grow to its current size. Yet this newly discovered black hole reached a colossal mass when the universe was barely 3% of its current age. It's like finding a fully grown oak tree that is only a few weeks old. This discovery forces us to confront a fundamental puzzle about cosmic evolution. How could a black hole grow so big, so fast? The standard model of gradual growth simply does not seem to work here. There wasn't enough time. There wasn't enough available matter in a young, sparse universe for it to consume. It suggests that perhaps the very first black holes didn't form from dying stars at all. Maybe they were born differently. Perhaps they were born big, from the direct collapse of unimaginably vast clouds of primordial gas, creating seed black holes that were already thousands or even millions of times the mass of our sun from the very beginning. Seeing this object in its host galaxy, Capers LRDZ 9, also gives us a unique snapshot of the early universe. We are not just seeing a black hole in isolation, we are seeing it as part of a developing cosmic ecosystem. The immense gravity and energy pouring out from this black hole would have had a profound impact on the galaxy forming around it. It could have triggered furious bursts of star formation, or it could have blown away the gas needed for new stars to be born, stunting the galaxy's growth. We are witnessing the intricate dance between a galaxy and its central monster, a relationship that has shaped the cosmos from its earliest moments. This single discovery does more than just add a new object to our celestial catalog. It fundamentally challenges our established narratives about how the universe grew up. For decades, the prevailing story was that galaxies came first. Tiny clumps of matter and dark matter slowly pulled together under gravity, forming the first small galaxies. Then, over eons, these small galaxies would nurture the growth of black holes at their centers. It was a picture of slow, steady, bottom-up construction. The galaxy was the parent, and the black hole was the child that grew within it. This new finding suggests we might have the story completely backwards. The presence of a 300 million solar mass black hole in such a young galaxy suggests that perhaps the giant black holes came first. Or, at the very least, they grew up alongside their host galaxies in a much more rapid and dramatic partnership than we ever imagined. Perhaps these primordial black holes acted as cosmic anchors. Their immense gravity could have pulled in vast quantities of gas and dark matter, providing the seeds around which the first galaxies then formed. In this revised story, the black hole is not the child of the galaxy, it is the architect. It is the gravitational scaffold upon which the very first great cosmic cities were built. This idea has profound implications for our understanding of cosmic structure. If massive black holes were common in the early universe, they would have been a dominant force in shaping everything that followed. Their incredible gravitational pull and the intense radiation they emitted as they fed would have influenced where and how stars formed on a grand scale. They could have helped to ionize the hydrogen gas that filled the early universe, ending the cosmic dark ages and allowing light to travel freely. They might be the missing ingredient that explains the rapid formation of the large-scale structures, the filaments and clusters of galaxies that we see in the universe today. We are forced to reconsider the very nature of galaxy formation. It might not have been such a gentle and gradual process. Instead, the early universe might have been a far more violent and dynamic place, dominated by these gravitational behemoths. The relationship between a galaxy and its central black hole seems to be more of a coevolution, a symbiotic dance where each partner influences the growth of the other from the very beginning. This discovery by Webb is like finding a new chapter at the beginning of the cosmic storybook, one that changes the plot of everything that comes after it and reveals the characters to be far more powerful than we knew. Every great discovery in science answers one question while opening up a dozen more. This ancient black hole is no exception. Its existence poses a thrilling new set of puzzles for astronomers to solve. The most immediate question is this object a rare fluke, or is it just the tip of the iceberg? Are these oversized, primordial black holes common throughout the early universe? If they are, then our entire model of cosmic evolution needs a significant overhaul. The James Webb Space Telescope will now be tasked with hunting for more of these ancient giants to determine if Kuiper's LRDZ9 is a lonely anomaly or the first of a whole new population of cosmic objects. Scientists are also desperate to understand how these monsters could have formed. The theory of direct collapse, where massive gas clouds bypass forming stars and fall directly into a black hole, is a leading contender. But we need evidence. Webb and future telescopes will search for the specific signatures of this process. They will look for black holes that are overmassive compared to their host galaxies, a key clue that the black hole came first. They will also analyze the light from the material swirling around these black holes, looking for chemical fingerprints that could tell us about the pristine, primordial gas from which they might have been born. Furthermore, we want to know more about the intricate relationship between these black holes and their galaxies. How exactly did they shape the first generations of stars? Did their powerful outflows of energy help or hinder galaxy growth? By studying the stars and gas in the host galaxies of these ancient black holes, we can start to piece together a direct, observational picture of this co-evolution in action. We can watch, across 13 billion years of distance, as the fundamental building blocks of our modern universe are forged in the crucible of these powerful gravitational engines. It's a chance to witness galaxy formation as it happens. This is what makes science so endlessly exciting. We are standing at the edge of a new frontier in our understanding of the cosmos. The universe, it seems, is always more ingenious and more surprising than we can imagine. The James Webb Space Telescope is our guide on this journey, pushing back the darkness and revealing the secrets of the dawn of time. Each new image, each new piece of data, brings us closer to answering the biggest questions of all. Where did we come from? And how did the universe become the magnificent star-filled place we see today? The search has only just begun.